Okay, let's do one more hypothesis test example. So again, the first thing I notice when I start reading this question is I see that word mean, and I note that this is going to definitely be a T-stats calculation. So the mean weight of all 20-year-old women is 128 pounds. A random sample of 40 vegetarian women who are 20 years old showed the sample mean of 122 pounds and a standard deviation of 15. The women's measurements were independent of each other. So we want to determine whether the mean weight for 20-year-old vegetarian women is significantly less than 128, using that standard significance level. So the difference here is we just have blank space now. We are in charge of fully creating this hypothesis test on our own with kind of no leading through it. So I have to remember for myself that the first thing I want to do is write my hypotheses. So I've got to create my null, create my alternative. These are means, so they're both going to start with mu. The boring stance here would be that the mean is equal to 128, that there's no difference at all between the vegetarian 20-year-old women and the just regular meat-eating 20-year-old women. And here reading very carefully, we are trying to test if it is significantly less than that. So specifically here we have direction. Is it less than 128? Okay, then I have to kind of remind myself of everything and make sure my conditions are met. So as a reminder, the alpha value here we're using is 0.05. Is the condition met to actually continue? The sample was of size 40. So we've met our condition. So we're good to go on that. Okay, now we are going to compute. So I have to remind myself, where do I want to go? I want to go in StatCrunch to T-stats this time, and I want to find the T value and the P value. Those are the important numbers to get back. And then once I find those, I can write my conclusion. So let's see, when we go in there, we're going to need the sample mean, which is 122, and the sample deviation, which is 15, and we need that, the 40. So those are the values I need. T stats, still one sample, still with summary. So it's, again, we don't have a list of every single woman and all of their different weights. We have a summarized information of that. So the sample mean was 122, the deviation was 15, and the sample size was 40. Running a hypothesis test, testing is their average weight equal to 128, or is it less in this case? Remember, you do have the option to make a p-value plot if you wish to, which just means it will always show you this page where it'll tell you your t-stat and your p-value, and I'm going to record that in just a minute on our paper. But remember, you can always get a visual of what's happening here as well. So you've got your t-distribution, you've got the t-value of negative 2.5 plotted over there, and then you've got it shaded below there to give you a really good idea of the very small likelihood, a very small probability that what we just saw was due by chance, that the measurements came out so much different from 128 just by random selection. Okay, so my t was negative 2.53 approximately, and the p was 0.0078. So in 4, I want to make my conclusion. So I use that p-value and I say since p, and in this case p again came back less than alpha, so we will reject the null. Seems as though there's enough evidence to conclude that the mean weight of vegetarian women aged 20, I mean it's a very specific category here, is less than 128.